Welcome back, AP Calculus, to part 3 of our exploration of pre-calculus review. We're going to be talking about absolute value inequalities and what the deal is with those. Number 35 shows us it presents to us, we got an absolute value compared to a constant number, and we've got a less than symbol in there. Now keep in mind, absolute value doesn't change from the whole piecewise thing that we did before. Remember when we did piecewise and we said, all right, wherever it splits off, in this case it would be at -5/2, the place where it's 0, wherever it splits off, it's going to be the positive version of that versus the negative version of that. There's no difference with this example here. So we're solving the positive version of that inequality, where that basically means the inside is unchanged. And then we solve the negative version of that. Hopefully that makes sense. And really from there, it's just doing basic Math 1 type stuff. Remember, there's a concept about dividing by negative numbers that switches the direction of the inequality symbol. Since we're dividing both sides by 2, it doesn't matter if the top's negative. It doesn't switch the symbol for this case. So there's one part of our solution set. Now the other part, you can do a little shortcut here. Instead of distributing that negative every single time, we could just say, hey, divide both sides by that -1, because it's like there's a -1 on the outside of the parentheses, and then we're left with no negatives on the left-hand side. Now, dividing by a -1 on the right-hand side will require that less than symbol to switch to a greater than symbol. And then solve from there. All right, so we've got 2 parts to a solution here. Now, you don't have to really test any intervals in these absolute value situations, but you do have to you have to have an understanding of when it's shared space and when it's like when it's an intersection versus a union of 2 inequalities. So in this case, whenever you have less than, it just means you're taking a distance, an absolute value representing a distance, and you're saying if it's got to be less than something, you are in a tight squeeze. You can't be less than 0 because it's like distances have to be like a whole number amount. Like you can't have a distance of -25 miles. You can go left, you can go right, but that distance has to be straight up 25 miles? Yeah, 25 miles. So, that always means shared space will be less than united space. So you're using and whenever it's initially less than, when the absolute value is less than. So one way to think about that is, okay, it's got to be less than -1/2. That's the larger amount. But you can also say that x is greater than -9/2 in that same statement. So from x's perspective, x is greater than -9/2. So you can use a compound inequality to express the final answer in a initially less than absolute value inequality. If you want to put that in interval notation, you just use parentheses because they're both neither of them have an equal to sign. And that's also a good one. I think in the directions they said use intervals whenever possible, so that'd be your answer. All right, so let's say it's not a less than symbol. Let's say it's a greater than symbol, okay? Well, I've already done the first step for you guys. If you check this out, Oh boy. All right. If you check it out, I just dropped the bars and rewrote the inequality. Just like over here, you dropped the bars and rewrote the inequality. And then I took the inequality greater than and made it less than because I changed the other side to a -6. It's like in my mind I said, okay, this is the negative version of that, but I already divided by the -1. See, we can do that shortcut where you divide by -1. You can just say, flip the symbol and make this negative. I think I'm probably explaining that overkill-wise here, but just I think you guys get it. Solve each inequality. So again, I don't think you're seeing new information here. Just make sure you're paying attention to dividing by negatives. If it happens in the course of any inequality, you have to flip this symbol. So, 2 3/7. All right, now this is a different situation. The greater than 6 means that this distance has a huge, like think about what it means to be greater than 6. The distance can be greater than 6. Wow, so the distance can be 80 trillion. That means you're going to have opposite type behavior. The intervals are going from in negative infinity to somewhere and going from somewhere to positive infinity. So that would be a usually like a union type statement, like an or statement. So if it's a greater than, you're always dealing with or situations. So x is less than -2 3/7, or x is greater than -5/7 would be the appropriate way by which to express that solution in inequality notation. Again, if we're talking about intervals, it'd be -infinity to -2 3/7, parentheses, or actually, here's the union symbol. I think you'll see that every once in a while in a textbook. -5/7 to infinity. All right. I think the next two examples I'd like to show on a separate video because they're kind of totally different concepts. So yeah, part 4 coming up.